is about the Orion test flight, liftoff to splashdown, and they basically talk about, what needs to be done in order for this project to take place. And so NASA engineer Kelly Smith is on there, he's explaining stuff, but he says something really interesting. So let's check this out.
As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space.
Wait a minute. We must solve this issue before sending people through this space? What happened during the moon missions? Didn't they go through the Van Allen belt as well? So, I don't know. Just wanted to point out this discrepancy where in this video, this guy is talking about how the equipment can fail and the navigation can fail and we're going to have to figure this out before we put people through it. Well, what's to figure out? Didn't you guys figure that out like 50 years ago or something? Just very strange that they would say that. Did they spill the beans? Maybe. Well, if you
two special guests from International Space Station, Terry Virts, the current ISS commander, and Samantha Cristoforetti, the first Italian female astronaut in space. Hi Terry, buongiorno Samantha. Thank you very much for joining us on Euronews. I would like to start by asking how you feel about the other 3 crew members returning to Earth. As the next crew will arrive at the end of March, do you feel a bit lonely up there in space?
You know, it was sad seeing.
And what comes after the International Space Station once its mission is over? How do we ensure the presence of humans in space?
Well, that's a great question. The plan that NASA has is to build a rocket called SLS, which is a heavy lift rocket. It's something that is much bigger than what we have today, and it will be able to launch the Orion capsule with humans on board, as well as landers or other components to destinations beyond Earth orbit. Right now, we only can fly in Earth orbit. That's the we only can fly in Earth orbit. That's the farthest that we can go. And this new system that we're building is going to allow us to go beyond and hopefully take humans into the solar system to explore. So the moon, Mars, asteroids, there's a lot of destinations that we could go to. And we're building these building block components in order to allow us to do that eventually.
Orion is getting ready to launch. My name is Kelly Smith, and I work on navigation and guidance for Orion. Orion is NASA's next-generation spacecraft. Built with versatility in mind, it can take astronauts deeper into space than we've ever gone before, to an asteroid or even onto Mars. For these missions, Orion has to be one tough spacecraft, withstanding high speeds, searing temperatures, and extreme radiation. Before we can send astronauts into space on Orion, we have to test all of its systems. And there's only one way to know if we got it right. No astronauts will be aboard. The spacecraft is loaded with sensors to record and measure all aspects of the flight in every detail. It all begins with launch, aboard a Delta IV Heavy. As the spacecraft and the upper stage begin their first lap around Earth, Mission Control in Houston is monitoring the progress of the flight. Orion's over 100 miles up and going about 17,000 miles per hour. Just as it passes over the Indian Ocean, we lose communication. As we get further away from Earth, we'll pass through the Van Allen belts, an area of dangerous radiation. Radiation like this could harm the guidance systems, onboard computers, or other electronics on Orion. Naturally, we have to pass through this danger zone twice, once up and once back. But Orion has protection. Shielding will be put to the test as the vehicle cuts through the waves of radiation. Sensors aboard will record radiation levels for scientists to study. We must solve these challenges before we send people through this region of space. It's great to be a part of this first space flight for Orion, and we're looking forward to beginning a new chapter in human space exploration.
This is a group of social criminals, these people in the space program. Nassholes, I call them. In case you haven't heard, the latest disaster for the rest of the universe is that the United States is going to go to Mars. Okay? Oh, yeah. We're going to go to Mars. And then, of course, we're going to colonize.
Question number two.
Wait, but you gotta know, let me just so you understand. We've been fed a lie our entire, I want to call it a lie. We've been fed.
It's a point of view thing, I think.
Earth has been misrepresented to us by geologists. Because the globes that you buy, that you rub your fingers over and you feel the Himalayas and you feel the Rocky Mountains. No.
And what you're seeing here is a mirage. We typically would not be able to see this from the Lake Michigan shore. We talked about this last night. Conditions are right on the lake, but we're actually seeing a mirage.
Let's look at an example of such craziness that it actually almost single-handedly got me a full belief in the flat Earth. And that is between California and Hawaii, 2,468 miles. Take that number times 2468, 8 times 2468 times 2468, and you get some incredible amount of inches. I think it's like 50 million. Divide that by 12 and you get 4 million. And then you can take that 4 million and divide that by 5280 to go from feet to miles. And your answer is 769 miles of curvature. Look it up. Again, don't ever believe me. Don't think I'm telling you to believe me. I'm not trying to fool anyone. That is the answer. So, knowing that, imagine a few things for me. For instance, the ISS flies about between 150 and 250 miles in space, supposedly. Now, how would there be a 769-mile-high hump in between California and Hawaii? Well, believe it or not, wake up, knock knock, McFly, anyone there? If you believe in the globe, then you believe there is a hump of water that is 100 times higher than any plane flies in between California and Hawaii that cannot be measured, that you call science. Cannot be measured or tested, you call it science. Scientific method, yet you don't use the scientific method. It just makes no sense.
35 seconds, 135,000 feet into the flight.
Looking for an 87-second burn. Uh-oh, uh-oh, uh-oh.
He's in a roll, it appears, at this point. Does not appear to be a scripted maneuver.
Shut down. Come on, Mike.
We have shut down main engines to Spaceship One.
The horizon line is flat, which is impossible if the Earth is a convex ball. So this kind of bothers me. It really intrigues me, seeing I have a science background. I have a bachelor's of science in mechanical engineering and have always been intrigued by science. Read many books on evolution and creationism and all these different topics. And with mechanical engineering, you do a lot of math, and you do a lot more than that. You do vibration, statics, dynamics, thermodynamics, all manner of different types of analysis with physics, and they're just highly detailed analysis in various realms of physics, where you take friction into account, or vibration, or all these different things, and you end up with formulas this long, literally, with 20 variables, and then you end up doing 20-page calculations. I even had one that was like 40 pages long calculation. Yeah, so you actually do mathematical problems that could take 40 pages to solve. You remember when you were in school and you did like this long of a calculation? So that's the kind of background I had when I was in college. And this really bothers me. See, a lot of people, they just drink the Kool-Aid, they just believe whatever they're told. But the concern I have here is, why is the horizon line always flat? That should really...
Galileo is probably rolling in his grave. A Saudi cleric said our planet doesn't revolve around the sun.
Let's say we go to Sharjah Airport to travel to China by plane. Understand? Now focus. This is the Earth. Say it rotates and we leave the airport. The Earth is rotating, right? So if you say the plane stops still in the air, wouldn't China be coming towards it? Yes or no? If the Earth rotates in the other direction, the plane will not be able to reach China because China is also rotating as the plane rotates.
Get it? The Earth doesn't revolve around the sun, or planes would never get to their destinations. Some Saudi cup of water physics. Well, the man's theory is quite popular, at least online. It's an instant viral tweet subject trend on Twitter. Some say the Saudis finally got it right after all the years of what we learned in school. This user looking forward to the cleric's